Hello and welcome. Today we're going to be doing some further maths and the topic is conic sections. I just want to say first of all, some people are asking me why don't I do more exam style type of questions, maybe for mechanics, stats, anything. And this actually illustrates why I don't, and I normally do a lot of integrals, a lot of serious one-liners essentially, because it's very, very difficult to actually write the givens in a question in a standard or typical rather exam question on the board. So I'm going to make an attempt today to do a question which I wrote all the key information in there, and I hope I've written enough for you to follow. I wrote this question only very recently, and I haven't decided yet whether I'm going to structure it as a part A, B, C in order to assist you, in which case it will be doable and by normal sort of like but the ordinary sort of further mathematicians, or shall I just leave it as enrichment and just say this is the givens, just get on with it, in which case if I do this, and perhaps that's how I'm going to present the question, not because of that reason, it's purely because I don't want to be writing a lot of stuff up here, then it'll be a 5-star question, quite difficult. Okay, let's see what the question is actually saying. And I've written the key points up there. We've got an ellipse given parametrically with these equations. X is 3 cos theta, y is equal to 2 sine theta. The theta runs between 0 and pi over 2, so clearly it's only the part of the ellipse on the first quadrant, on the top right of your axis. Then a normal at some point P on this particular ellipse meets the white axis at the point Y. So I could have actually said to you there, find the equation of the normal or something like that. Then the midpoint of the point P and the point Y is denoted by M. So P is here, Y has been defined there. So the midpoint of those two is the point M. And then I'm actually saying to find the maximum area of the triangle OMP. M has been defined, P has been defined, and O, perhaps I should write, it is actually the origin. Okay, so of course in a question you cannot assume O is the origin unless it tells you, but here I'm just pressed for space. So this is the question now. I'm going to attempt it. I'm not quite sure what conic sections are these days in the exams. Of course, different boards have it in different modules. So I don't know if that's further maths if you prefer it. Like the in Excel you have the further core now. One of my students told me, and the further pure. So I still haven't understood what's going on with these modules nowadays. Okay, let's start the question. First of all, it's talking about normal, therefore we're talking about gradients, about equations of tangents and normals. So I have the question in parametric, so I'm going to find the gradient function in parametric. So dy by dx, divide top and bottom by d theta. Okay, so dy by d theta is 2 cos theta, and dx by d theta is minus 3 sine theta. And this is of course the gradient function. Where do I need the gradient function? The normal at some point P. The general point P on this ellipse, I'm going to write here, is of course the point with these coordinates, where theta is now just the value of the parameter. So you can actually sloppily write it as 3 cos theta. So it's a dummy variable as well as the value. It's a bit, I don't like doing that, but I think even exam questions actually do this these days. P is the point with coordinates 3 cos theta, 2 sine theta. Yep. So the dy by dx, therefore, it's a bit silly. I'm not going to write it. It's a bit silly. This is my gradient function, and therefore the dy by dx at the point P, where P is this point here, I will substitute the value of theta. So basically at that point theta is actually theta, that's what it's actually saying, is of course this 2 cos theta over minus 3 sine theta. So that's the gradient of the tangent. Therefore normal gradient is my next step. Normal grad will be equal the negative reciprocal of that, so it's going to be of course positive 3 over 2, And I could write as a tan, but I'm going to leave it as sines and cosines, probably a little bit better for this question. So 3 sine theta over the cos of theta. So that's the normal gradient. So the next step is to find the equation of the normal. Y minus the y coordinate. The normal is taken at P, and P has these coordinates. So y minus the y coordinate of my point, minus 2 sine theta, is equal to the gradient of the normal, 3 sine theta over 2 cos theta, x minus the x coordinate of my point, which is this thing here. Do I need to simplify this expression? The answer is no, as I'm setting up the question. And if the question was structured, of course, and it said find or show the equation of the tangent is the normal is such and such, you would. But here I'm not really interested in this equation. The normal at some point P on this ellipse meets the y-axis at the point capital Y. Therefore, all I need to do here is meets the y-axis, x is equal to 0. So I'm going to put x is equal to 0 and get the y coordinate. So if x is equal to 0, I'm going to get y minus 2 sine theta. This will be 0 now. And this will multiply to equal to, the causes will cancel. Let me actually write it. 3, put the minus, sorry, I'm doing stupid things at times, doing too many things, too many thoughts I come to my head all at once. So I got 3 times 3 minus, I've taken care of, sine theta, cos theta on the numerator, and then I've got a 2 cos theta on the denominator. And of course, on your next line, you can cancel the cos, top and bottom. And therefore, you're going to get 9 over 2 sine theta. And of course, take this negative 2 sine theta to the other side. Negative 9 over 2, 4.5, 3.5, 2.5. I'm making y is minus 5 over 2 sine theta. So the point y now, I'm going to write it somewhere so I have it for reference. The point P, I need it. Okay, I need the point M next, but we need the point Y for the time being. Let's write it here, maybe here. The point Y, which is where the normal meets the y-axis, has coordinates 0, x 0, and y is minus 5 over 2 sine theta, is general coordinates. Okay, so far what we've done, we have established the coordinates of y, then the midpoint of the point P and the point Y is the point M. This we can do by inspection, or you can write some workings in there. It's the average of the x coordinates and the average of the y coordinates. 3 cos theta plus 0, take the average of that, is going to be 3 over 2 cos theta. And the average of that and that, that's add them together and divide by 2. So it's going to be minus a half sine theta when I add them. And when I divide by 2, I'm going to get minus a quarter sine theta. So now I have the coordinates of M, I have the coordinates of P, and therefore I need to find the maximum, says, area of the triangle OMP. Let's not worry too much about the maximum for the time being. Let's see, where is this triangle first of all? Okay, I need a picture. There's no way I can, well actually there is a way. I'm going to show you something. If you're a mathematical heavyweight and this is your what you got in there, the question from this point onwards is just literally 30 seconds, okay? But this is something that is not being taught these days. You probably haven't come across it. I will call it strictly enrichment. It's for people that do a lot of reading. Yes, I can find the area of this triangle very, very quickly. I'll show you at the very end, okay? We're gonna do it with a method which requires us to actually see things, and perhaps it'll be long, but at least we'll be satisfied we've done it correctly. Okay, so first of all, let's see what these points are. Oops, that doesn't write now. Okay, let's put in the bin. So this is like my coordinate axis, everything is happening on, because the theta runs between 0 pi over 2 is up here. So first of all, the origin is here quite clearly. And where's P? That's the point of normality. My ellipse would have looked something like that. And P would have been somewhere up here. Coordinates, 3 cos theta, 2 sine theta. So let's say this is here somewhere. That's the point P. 3 cos theta, 2 sine theta. Okay, where's the point now? That's O. And where's the point M? So OMP. M has x coordinate 3 over 2 cos theta. So it's not that I'm drawing it to scale, or I'll do it on a graph paper or anything like that, but I want to have some relative scale because I need to see what is going on, and it will help me. So that's somewhere halfway here, so somewhere along this line, and it's only marginally below the x-axis. We go minus a quarter sine theta, so the triangle looks something like this. Okay. And let's close it. And this is the point M with coordinates 3 over 2 cos theta, yeah, minus a quarter sine of theta. All right. Please do not do anything stupid, because that's the way I draw it. It looks like there's a right angle there. I don't think there's a right angle. Perhaps we can check if they are perpendicular, these line segments. Maybe they are, I don't know. I don't expect them to be. So I will use a general method. How I'm going to find the area of this particular triangle? Well, from geometry, ordinary geometry, I'm going to draw some extra lines there, but I'm going to remove them, maybe draw another picture to see what I'm going to do. Because unfortunately, drawing on the board is not very nice, and I would have liked a better, slightly bigger picture. I'm going to split that into 2 triangles, okay? This one and this one. Of course, they share the same base. This is the base. And the height of the triangle which is above the x-axis is here. So that will be the height. So if I find this length, the height, of course, I know what it is 2 sine theta. It's a half base times height. So for the top triangle, it's all about finding this length. For the bottom triangle, the one that's upside down, if you see it this way, it's again the same base, which I would have needed to find the area of the triangle on the top, and the height of this triangle is, of course, here somewhere. And I have this height again. It's, of course, I will ignore, of course, the minus on the minus a quarter sine theta on the y coordinates, simply a quarter sine theta. So the question now is, how do I find this length? Maybe I can actually not draw another line in there. It's all about similar triangles. So I'm going to shade this, and I'm going to shade this, and I hope the picture does not get too messy and we can all see what is going on. Let's use some different color pens as well with this. Let's look at the heights. This triangle is quite clearly similar. So if we look at the heights, this is 2 sine theta here, and this is a quarter sine theta, forget about the minus. So that is in the ratio of 8 parts there and 1 part there. Okay, so that is definitely the scale factor. So I could work out, perhaps, okay, because I have obviously the x coordinates, and that's 3 over 2 cos theta from here. I'm going to put a little arrow. This is 3 over 2 cos theta, and where this arrow goes on the other side is, of course, 3 cos theta. So the difference between this point here, where I put the arrow, and the other one is in fact still 3 over 2 cos theta. 3 take away 3 over 2 is 3 over 2. Okay, so this will also be in the ratio of 1, this part here, to 8, because of course the triangles are similar. So if I share now the difference between the 2 arrows, this length is going to be 3. I'm going to put some work so you can all follow what I'm doing. 3 cos theta, take away 3 over 2 cos theta. Maybe you can see it and I'm showing you the obvious. I do apologize if I'm just insulting people's intelligence perhaps. So this length is 3 over 2 cos theta, and is 9 parts in there, of which 1 part is there and 8 parts are there. Okay, so I'm gonna take the 3 over 2 cos theta, this one here, divide it into 9 equal parts. So divide by 9, which of course is the same as multiplying by 1/9 cos theta. And this will give me 3 over 18, 1/6 of cos theta. Where is that 1 part? This is this length here. That length here is 1/6 of cos theta. Therefore, I know how far it's from the origin to this point where the arrow is, because that's the x-coordinate of M. So the base of both of those triangles are in fact 3 over 2 cos theta, that's this length here, plus 1/6 of cos theta. 3 over 2 plus a 6 is a 5/3, 18, 20, 20 over 6, 10 over 3, 10 over, wait a second, 3 over 2, gosh, brain is misfiring again. So it's 5/3, I think, 18 plus 2 over 12. Have to excuse me, I'm getting old. 20 over 12. 20 over 12 is 10 over 6. And I do a lot of stupid things. Therefore, I found it is in fact, yes, you can use your calculator, I guess. It's 5 over 3. It's correctly my first feel for the number. It's 5 over 3 cos theta. So that is actually from O until the point where this line crosses my x-axis. And therefore, I can now work out the area of the required triangle. The triangle on the top has an area of a half, base, the base of course 5 over 3 cos theta, times the height of the triangle, and the height of the triangle is 2 sine theta. And to that I need to add the area of the triangle that's underneath, which of course is a half. It has of course exactly the same base, 5 over 3 cos theta, and the height of this triangle, we're going to ignore of course the minus, is times 1/4 sine theta. And let's see what is the final answer for this. We have, when we add them together, the 2 and the 2 will cancel there, so that's going to give me 5/3 cos theta sine theta. And from this one, anything cancels there. The answer is annoyingly no. 5 over 24 cos theta sine theta. I wish I had taken a calculator, because I'm a little bit embarrassed when I see my year 7s will be laughing now at me. Say, sir, cannot add fractions. Gosh. Okay, so that's going to be a 5. I'm going to factorize at the front. So I got 1 over 24 plus a third, which of course is going to be 8 over 24, which is 9 over 24. So it's 5 times 9 over 24. And 9 over 24 will cancel again to a 3. What am I doing? Dividing by 3. So it's 3 over 8. And that is going to be 15 over 8. I make this because I haven't got the calculator in front of me, that the area of the two triangles combined, so the area of OMP is, would that make it 15 over 8, 15 over 8, and of course is lots of cos theta. It's a function of course of theta, because of course we know nothing about where we drew the normal. It's just a general expression. So at least we have a general expression now for the area of the triangle. So we need to maximize it, because the question says find the maximum area of this particular triangle. Do we need calculus for something like that? The answer is no. This is so simple, it's beyond belief, but it does require trigonometry and a little bit of ingenuity, and perhaps having seen things like that before. This is of course your double angle in in sine. So you can write this as 15 over 16 lots of sine of 2 theta. So that is the area of your triangle. And we should be able to see that the most this value, sorry, this quantity can become is 15 over 16th when the sine of 2 theta becomes positive 1. Okay, so what does that actually say? We can actually say that when theta, in fact, it doesn't actually ask us for that, when theta is pi over 4, so if you can imagine the ellipse would have looked something like that. I don't know, something like this. And we took, there's your tangent, your normal, it's not going through the origin, it's not very badly drawn. When the parameter becomes, when the theta becomes pi over 4, we're gonna get this particular expression, because of course now this, okay, will become 1 when we're putting pi over 4 in there, and therefore area max, I hope I'm explaining this well and you're following, is 15/16, and that's all there is to it. This question can be a bit tough if you see it, of course, there's the givens, get on with it, but if you put some structure, of course you should get some marks for doing bits along the way. That last part can be quite tough to see how it's done, and as I promise you, you know, when we don't, most of our work was actually wasted in doing this, and actually this, to think of it, is not that straightforward as now perhaps looks like, but I promise to show you that if you know the 3 points, arbitrary points, you can find the area, and remember the area we got was 15 over 8. Let me just write it somewhere so we know what we're expecting to get. 15 over 8, sorry I'm writing sideways, cos theta, sine theta. I'm going to show you a different way. This probably you haven't seen before. I hope they include it in marking schemes, because I don't know who marks papers these days, and they give you full marks if you ever have to use something like this. But it's very, very cool and very nice to know. This is what it says. If you have 3 points with coordinates x1, y1 in the 2D plane, on the xy plane, x2, y2, and x3, y3. The area of the triangle, with straight sides of course, rectilinear triangle, that connects these 3 points is given by this determinant. The area is equal to a half, and I'm gonna say something else after that. It doesn't matter whether you write it as 1, 1, 1, or you put the ones, because of course determinants can transpose. So x1, y1, x2, y2, x3, y3. You compute that and that's your area. And of course there is a little bit that I must add in there. It looks a little bit crazy when you write it. I'm going to put another line, straight line like this, and this is the determinant on the side, and this is the modulus, of course, of your determinant. So if that turns out to be a negative quantity, you ignore the minus and you just divide by 2. The minus just simply says your triangle is upside down, it's flipped. That's all. So let's do it for our particular example. So in our case, we have the coordinates. The third coordinate, of course, is the origin, which is 0, 0, which will make the calculation absolutely trivial. I did say you will need literally 30 seconds to do this. So the answer is a half, 1, 1, 1, 0, 0. The other point is 3 cos theta, 2 sine theta. Let's make a little bit more room, 1 there. And the other point is 3 over 2 cos theta and minus 1/4 sine theta. That's what the coordinates are. And let's compute this determinant and let's see if indeed we're going to get the answer that we're expecting. And of course, if that turns out to be a negative quantity, I need to mod it. Okay, so let's put another straight line there. All right, that's going to be a half, and this of course will produce 0. All the other entries, the only entry that you're going to get, because it goes 0 there, is the minor for this one. So it's going to be that minus that. If you go there, there's nothing else, so therefore it's going to be equal to the modulus, that's the outside, of that times that, which is of course 3 minus minus 3/4 there, cos theta sine theta. Okay, that's that, minus 3 cos theta sine theta. Perhaps I should have written the points the other way around because I would have ignored the minuses. Okay, so that means the modulus will take care of the sine, so let's get rid of them. So we got 3 3/4. 3 3/4 is of course 12 15/4. Okay, so 15/4 cos theta sine theta, and 15/4 divided by 2 is 15/8 cos theta sine theta. That was the area of the triangle, and that's what we got obviously by doing all this geometry. So you can actually see how powerful this result is, and if you want to compute things of course for yourself, this is of course the way to go, not obviously with this complicated geometry. I hope you enjoyed it. I hope I didn't make a mess. It's very difficult, as you saw, to present an exam question with loads of wording in a lecture, but I hope you got something out of it. Join me again. Who's laughing now?